So in the previous part, we looked at how we can construct a baseline MLP model. We reached to the part of putting down the model compile and getting towards model fit. At this stage, it is important to learn the iteration levels that goes in when we are doing the model fitting. Why is it important? Because in this problem, and inevitably in some other problems as well, sometimes we have to do certain customizations. For example, in this chapter, we are going to learn about matrix customization. So let me put it down here. As I said, the major purpose of understanding iteration levels is so that we can do some customizations. In this chapter, we are going to learn about matrix customization, because the default matrix that are present with TensorFlow, they are not applicable on the problem we are solving. We are going to define some new matrix, and I'll come to that shortly. And further down the line, we will also define one of our own custom activation. Whenever we are defining our own custom functions, the custom functions are going to process things like these input samples, prediction, and outputs, and so on, at the same level at which this model fitting happens, at the same iteration levels. And therefore, it is critical that we understand the iteration levels in the process. So let's go through it. I can keep it here. The iteration levels that happens in this modeling, or for per se most of the deep learning modeling, it starts at the epoch level. Then it goes to batch level. This is pretty much common across most deep learning models. After this, it differs from model to model or network to network. In MLPs, there's nothing actually that happens after this. A batch is comprised of samples. But in TensorFlow, the computations do not happen at sample level. All the samples within a batch are processed together. Therefore, I'm putting samples in a different color, because this is just a logical level. In practice, everything happens at the batch level. So let's look at it visually, how that happens. Here, this is a very high level illustration of an MLP network. We start with a batch of X's, our samples. This is our model. Model is made up of parameters, specifically weight and bias for each of the layer. We can call all of these parameters together as theta. And this model will ultimately lead us to the output. The output is a prediction of my y, and again, for each input sample, we get a prediction. So if our batch size is NB, we get NB number of outputs here. I can put this shortly in this form. X as input goes to my model theta and returns y. Now, when we are training the model, we do it repeatedly, epoch by epoch. Now, what happens epoch by epoch? In epoch 1, we randomly initialize the model, meaning we randomly initialize theta. Randomly initialize theta. Now we go batch by batch. So this is my level 1, and then I go initialize theta to theta 0, for example. Then I randomly take a batch, make some predictions, y hat. These predictions are gonna give me some error, this. These error will be back propagated into the model, and a new batch will be taken in. So let's say I call this whole batch as 0 batch. Now a new batch comes in. The model is relearned using this new batch and the error that was computed in the previous batch. And this process continues until I exhaust all the batches that I can get out of my entire data set. So, to summarize again, start with an epoch. I randomly initialized my model. I started with one batch, learned something, used that learning, and with the new batch, updated the model. This process repeated until I got exhausted with the batches I can get out of the data set. That finishes my first epoch, and now I go back to second epoch, and here, instead of randomly initializing the model, now I have the output that I got at the end of the epoch as the initial model here. So with this setup, what I'm doing is start with an epoch, learn the model iteratively batch by batch. The epoch ends. At the end of the epoch, whatever I learned goes back here, and in the next iteration I start from that learning. Again, I randomly take batches, go iteratively, and relearn the model. What happens at the end? Suppose I have from 2 to 100 epochs. Suppose I had set the number of epochs as 100. At the end of the 100th epoch, I would have gotten a set of parameters, theta 100. This is my trained model that I can use for inferencing. And if I choose to, I can again relearn the model, and I can start from theta 100. I do not have to restart the training. This is a small trivia I'm adding here to emphasize that whenever you are building a model, and suppose a model training takes significant amount of time, you do not have to do it at once. You can do it over time as well. You can always start from where you left previously. Now, coming back to the part that how this learning, this understanding helps us in customization. In the next part, when I'm going to build a custom metric, there we are going to see that within these custom functions, the input to these custom functions get from a batch. We'll highlight it here. So whatever happens within a batch in this process, that goes as an input to my custom function, and I have to build a custom function which can process a batch at a time.